overview of the artificial neural network. That's inspired by the neural network of our own brain. So first, let's back up a little bit. Think about the difference between computer and the human thinking. Well, let's start from the physical level. In the physical level, computer now runs millions times faster than the human neuron file. We are talking about milliseconds, but the computer now is talking about nano. It's more than nano now. It's a picosecond, right? Millions times faster computer, and the computer has a much big memory than human now, because especially the extended memory like IBM Watson. When you think about it, they win the Jeopardy in 2011, behind them is about like I think how many 20 big frame of memories there behind. That means you're talking about thousands of tera memory, basically bake any knowledge in the world there. Okay, that's our deficiency. But what's our advantage for human?
Massively parallel.
Massively parallel, you're right. When we are thinking anything, we're talking about millions of neurons are activated, just like a pile of ants are activated to find one connection. So we are massively parallel, and we are error tolerant. That's the key. If we get a little bit goofed up and get a little bit error, sometimes we still close. But the computer can completely give you a nonsense or crash. But we're not going to crash. We just, at the worst, give you some nonsense, right? So we are error tolerant. That's in the physical level. But in the deep level, we still don't know. The truth is, we still don't know much about how human. We try to get into those chips. IBM started a job, and Brown University worked at this for probably 30 years, trying to simulate the human brain. So there are some success, but not as impressive as we would like. So what is it? You get the input, you get output, you get the hidden layers, and when we talk about artificial intelligence, you always associate with the machine learning. Okay. Now, last time I asked you the question, what means learning? Well, I told you it's better to see machine training, but the learning is always a feedback system. Learning need the evaluate the performance, but not equal performance. If you just program the computer always reacts to what you programmed. That's not learning. Got it? The learning need to be feedback, compare your performance. The next time when it meet the same situation, they could do better. That's learning. Learning always happens when you can reflect what you did before, and the next time you can improve yourself. That's the definition of learning in the way. So in that way, you always have a little bit of memory associated, right? With, yes, question? So one concept is called perceptron. That's a long time, 50 years old now. Started from Franklin Roosevelt. And that's the time the human being has a huge dream about artificial intelligence after probably 10 years. So today we're going to look first the basic type of artificial network, ANN. And we look at the feedback, feed forward, but means no direct circle. Again, like the graph, you cannot circle back. And we can look for multi-layers And then we look at the recent progress. It's called a recurrent neural network. To get the net shell, look at this black box. What you learn is you have the input, and you also know the output. That's your training case. You know the attributes of the instance. That's 3 attributes, each of them are binary, and there's one output. The output is either 0 or 1, yes or no. So all you know is this 8-bit of input here. Then how do you put a box here to make sure each time you input those things, you're going to get the right output? That's the thing. Any machine learning is kind of learn from the input and output, that's all you know. And then you need to build a model here. So the model is pretty simple. In this case, we always start with the easiest case. If we just say each of the input have 1.3 weight, and in the end, you just add. This is like you use a Simulink, you put the add. Then you add the 3 input vote. If basically 2 vote yes is yes, 1 vote yes is no, right? It's just the majority win. Are you with me? It's just a vote. It's a voter machine here. And then you just take everybody's input, 0.3, and minus 0.4. That number 0.4 is called the threshold. Because if it's 1 vote, it's less than 0.4. If it's 2 vote or above, it's more than 0.4, right? It's like here, it's a voter machine, basically. This is so simple. Okay. So you all understand that. Now we start to abstract this idea to make it the easiest one, ANN. So here, this we call it weight. How much weight I give to your opinion. You don't have to be uniform. If in here have some expert know a little more, I give a little more weight, right? So in some company, you know, the stakeholder have a board meeting, who never have the big money has a big vote. Their vote may become proportional to the weight of their money. You got it? So that's what we're going to learn. Really, in this simple is don't have to be equal. The goal is very clear. You, based on this weight, you come up with an estimate. And you compare your estimate with the real result you know as a training case. And then you are going to adjust your weight each time to make your deviation from the real result smaller and smaller until it converges to a certain threshold. You say, stop, good enough. Make sense? That's all. So what we have is 2 functions. Here, the I, in this case, is the examples, the learning instances. And you put the weight with this xi at the attributes. And then you multiply, just give everybody's opinion a little bit of weight. And then you minus the threshold. And to see if you pass the threshold, it's yes. And below the threshold is no. Either you use a sign function. That means if pass, positive 1. Not pass, negative 1. Or use I means 1, 0. Same thing. Makes sense? This, you know, have to understand this baseline, then you can continue. So the T, the threshold, it's really you design.